Welcome to the DIY Honda Garage channel. DTC P2720 indicates a low voltage condition in the pressure control solenoid D control circuit, while DTC P2721 signifies a high voltage condition. These diagnostic trouble codes, DTCs, are associated with the variable transmission system in the Honda Civic models from 2016 to 2021. The codes point to electrical circuit problems rather than mechanical issues within the continuously variable transmission, CVT. The affected component is the pressure control solenoid D, which regulates fluid pressure in the transmission for optimal performance. These codes typically arise due to electrical issues such as short circuits, open circuits, or bad connections. Understanding and accurately diagnosing these codes is crucial for effective repairs and maintaining vehicle performance. The pressure control solenoid, D, plays a vital role in managing transmission fluid pressure, ensuring precise operation of the CVT in Honda Civic models from 2016 to 2021. This solenoid is located within the transmission housing, making it critical for maintaining proper gear shifts and overall transmission performance. When DTC P2720 or P2721 is triggered, it indicates issues in the electrical circuit associated with this solenoid. These problems can manifest as low voltage P2720 or high voltage P2721 due to various electrical anomalies such as open circuits or shorts. Understanding the solenoid's role will help technicians determine the appropriate troubleshooting steps and repair actions needed to resolve these codes effectively. The root causes for DTC's P2720 and P2721 predominantly stem from electrical issues within the circuit. These can range from simple wiring faults to more complex component failures. A short circuit may occur if wires are damaged or improperly connected, leading to unexpected voltage readings. In contrast, an open circuit may result from a disconnection or break in the wiring, preventing the solenoid from receiving the proper signals from the transmission control module, TCM. It's essential to approach these faults methodically, examining the circuit and connections for signs of wear, corrosion, or damage. Proper diagnosis will prevent unnecessary parts replacement and ensure the vehicle is returned to optimal working condition. When facing DTC's P2720 or P2721 in the Honda Civic, several symptoms may become evident during vehicle operation. A common indicator is the illumination of the check engine light, which serves as a warning to the driver. Additionally, the vehicle may exhibit shifting difficulties, such as hard or delayed shifts, making it challenging to drive smoothly. Drivers might also experience subpar acceleration performance due to improper fluid pressure regulation. Recognizing these symptoms helps in diagnosing the underlying electrical issues, guiding technicians to perform effective and timely repairs. Monitoring the vehicle's behavior during these symptoms can offer vital clues for troubleshooting. The first troubleshooting step for DTC's P2720 and P2721 involves accessing the vehicle's diagnostic system through the Honda Diagnostic System, HDS. Begin by turning the vehicle to the on mode, but without starting the engine. This allows the HDS to communicate with the vehicle's systems. After ensuring the connection, clear the stored DTC codes to reset the system. Following this, start the engine and wait for at least 1 second to allow the system to gather real-time data. At this point, check again for any pending or confirmed DTCs via the HDS. If the same codes reappear, it confirms that there is a persistent issue that needs solving. If no codes are present, it could indicate an intermittent failure, suggesting further investigation into the wiring and connections. Now, for the second step in troubleshooting DTC P2720 and P2721, start by turning the vehicle to the off or lock mode. Next, proceed to disconnect the TCM 50P connector, which connects the transmission control module to the vehicle's electrical system. With the connector unplugged, measure the resistance between test points 1 and 2. Test point 1 is located at TCM connector pin number 16, whereas test point 2 is the body ground. The measured resistance should be between 5.0 and 6.3 ohms for normal operation. If the reading falls within this range, the system is functioning correctly. However, if resistance is less than 5.0 ohms or more than 6.3 ohms, it indicates either a short or an open circuit, necessitating further investigation in the next troubleshooting steps. Continuing with troubleshooting, Step 3 requires you to disconnect the CVT lockup clutch control solenoid valve 2P connector. This process is essential for isolating the solenoid and checking for issues within the wiring. After disconnection, measure continuity between test points 1 and 2 while the vehicle remains in the off mode. Test point 1 should correspond to TCM connector pin number 16, and test point 2 is again the body ground. If continuity exists, it indicates a short to ground in the LCCLS, lockup clutch control solenoid, wire between the CVT lockup clutch control solenoid valve and the TCM. In this case, immediate repair is necessary. If there is no continuity, the LCCLS wire itself is functioning properly, suggesting a faulty CVT lockup clutch control solenoid valve that will require replacement of the valve body assembly. Step 4 mirrors the previous step in that it includes disconnecting the CVT lockup clutch control solenoid valve 2P connector. This step focuses on testing the LCCLS and LCC plus lines for continuity. Again, have the vehicle in the off mode during this procedure. Check for continuity between test points 1 and 2. This time, test point 1 corresponds to pin number 2 of the CVT lockup clutch control solenoid valve 2P connector, while test point 2 is TCM connector pin number 16. If continuity is confirmed, then the LCCLS and LCC plus wire are operational, which means that you can proceed to the next step. If continuity is not present, it indicates an open wire fault in either of these lines, necessitating repairs, specifically focusing on the wire connections between the solenoid valve and TCM. The final step of troubleshooting involves checking for continuity in the LCC- line. This check is crucial as it verifies the integrity of the wiring to the ground. With the vehicle still in the off mode, ensure both the CVT lockup clutch control solenoid valve 2P connector and the TCM 50P connector remain disconnected. Measure between test point 1, corresponding to pin number 1 of the CVT lockup clutch control solenoid valve 2P connector and body ground. If continuity is established, this indicates that the LCC wire is functioning correctly. Conversely, if continuity is absent, this suggests either an open circuit or poor ground at ground point G251. Appropriate repairs should be executed to rectify the wiring fault or improve the ground connection, which will likely resolve the DTC issue. After completing the necessary repairs indicated by the troubleshooting steps, it is important to perform final verification to ensure that the issue has been resolved effectively. Start by verifying the repair and confirming that no further faults exist within the system. Once you are confident that the system is functioning correctly, utilize the Honda Diagnostic System, HDS, to recheck for DTCs. Ensure that the previously logged DTC P2720 or P2721 do not reappear. If the codes have cleared successfully and the vehicle operates smoothly during a test drive, then it can be concluded that the repair was successful. Documenting the repair and any changes made during the process is also essential for future reference. To prevent the reoccurrence of DTCs P2720 and P2721 in the future, it is important to consider preventive maintenance practices for your Honda Civic. Regularly inspect electrical connectors, particularly the TCM and CVT lock-up clutch connectors, for signs of wear, corrosion, or loose connections. Ensuring that these connectors are secure and clean can help maintain optimal electrical flow and reduce the risk of faults. Additionally, pay attention to the wiring, making sure that there is no abrasion or damage that can lead to shorts or open circuits. Addressing these concerns proactively will not only assist in avoiding future DTCs, but will also enhance the overall reliability and performance of the vehicle's transmission system. In conclusion, DTCs P2720 and P2721 indicate underlying electrical circuit issues related to the pressure control solenoid D within the Honda Civic transmission systems from 2016 to 2021. Careful adherence to structured troubleshooting steps allows for accurate diagnosis and targeted repairs, ensuring that faults are resolved effectively. It is essential to confirm that repairs restore proper function and to monitor the system by checking for any reemergence of the DTCs. Additionally, incorporating preventive maintenance measures will aid in prolonging the lifespan of the transmission system, reducing the likelihood of future issues and enhancing overall vehicle reliability. Encouraging a combination of thorough diagnostics along with preventative actions ensures that the Honda Civic performs at its best. Please like and subscribe to the channel. See you next time.